Section 2.1. I did hand out new guided note packet. It is posted in Blackboard. This is the video that goes along with the first section of our new packet. So we're going to talk about lines. And we're going to warm up by looking at a rectangular coordinate system. So here's our x-axis. And here's our y-axis. And we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So quadrant 1, to move into quadrant 1 is plus, plus. To move into quadrant 2 is negative, plus. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So with that in mind, we need to determine where, if at all, these 6 points end up for quadrants. So the first is plus, plus, so that'd be quadrant 1. B is negative, negative, so we'd be in quadrant 3. C is negative 3, positive 6, so we'd be in quadrant 2. 7, comma, negative 5 is positive, negative, so we'd be in quadrant 4. E is in none, no quadrants, and F is in no quadrants, because if you do negative 3, 0, you go left 3, but that you don't go up or down any. So our definition here is a linear equation in two variables, looks like ax plus by equals c. An example would be 3x plus y equals 6. A solution of a linear equation in two variables is an ordered pair that makes the equation true. So as we begin, the directions say to complete the chart, find 3 solutions. So my first equation is 2x plus 3y equals 12. When I have an equation that has numbers in front of both x and y, I always like to use 0 for x and 0 for y. So I'd have 2 times 0 plus 3y is 12. That's gone. Divide by 3. So y is 4. So one of my ordered pair answers is 0, 4. If I do the next one where y is 0, I have 2x plus 3 times 0 is 12. This is gone. Divide by 2. X is 6. So then I have an answer of 6, 0. Now for the third, it's kind of a guessing game. I want to try to pick a number to put into x or y so that when I work it out and solve for the other, I get something nice. So let's put 3 in for x. So I get 2 times 3 plus 3y equals 12. So this is 6. So I subtract 6. So I get 3y is 6. Excuse me. I divide by 3, and I get y is 2. So my third ordered pair is 3, 2. Now the second equation is a lot nicer to build a chart with because one of the variables is completely isolated. So y equals negative 6x plus 3 is created to find y if you'd put an x in. So I'm going to pick all x's for my table. So we could just make it real simple and do 0, 1, 2. If we put in 0, negative 6 times 0 is 0 plus 3 is 3. If I put in 1, y equals negative 6 times 1 plus 3, which is negative 3. And if I put in 2, I get negative 6 times 2 plus 3, which is negative 9. Now, our table only had 3 rows in it, so that's all we needed to find. But the above equations have more than 3 answers. So do the above equations only have 3 answers? No, we could keep adding a row and a row and a row and find many more new answers. In fact, how many? We could find infinitely many ordered pair answers for both equations 1 and 2. So how do we graph a line? Okay, first off, linear equations graph lines, right? So we only need 2 points. My math lab sometimes might ask for 3. So how do we do this? Find 2 points on the line, pick any value, plug it in, and solve for the variable that remains. You can use an XY chart to help stay organized. Then you're going to plot each point, and you're going to draw the line. So for problem 1, I see that y is by itself, so I'm going to start my table with x's. 0, 1, 2 would be fine. 0 will produce a 2. 1 times negative 3 is negative 3, plus 2 is negative 1. Negative 3 times 2 is negative 6, plus 2 is negative 4. So I come over and I'm at 0 up 2. I'm at 1 down 1. And I'm at 2 down 4. I can see my 3 points line up, and so I have a good table. If I'm doing the second one, I have a fraction now in front of x, so some of the x's I used in problem 1 will be fine, but some will not. 0 will be fine. If I take negative 5 halves times 0, that disappears, so I get 3. If I put 1 in for x, then that doesn't help my fraction go away at all. So I don't want to put a 1 in for x. But if I use 2, if I put in the same x value as its denominator, I can see that my denominator and the 2 I put in will cancel. 2's over 1, and those drop out. So I get negative 5 plus 3 is negative 2. The same will be true if I use negative 2. So if I do y equals negative 5 halves times negative 2 plus 3, the 2's drop out, then a negative times a negative is a positive, so I get negative times a negative is a positive, so I get 5 plus 3 is 8. So I can plot my points, 0, 3, over 2, down 2, left 2, up 8, and I draw my line. Now, when we're freehand drawing lines, we can plot as many points as we'd like. When you're doing your homework in my math lab, and you have a table of 3 points, pick any 2 of them to plot, because my math lab will only let you plot 2 points to draw a line. So then we have a third one here. And the third one doesn't particularly have any variable isolated by itself equal to the other side, but we can see that x has no number in front of it. So x plus 2y equals 8 has no value in front of the x, so I'm going to pick all y values. So I'm going to pick 0, 1, 2 for my y values. If I put 0 in for y, I get 8. If I put 1 into y, I get x plus 2 times 1 equals 8. This is 2. Subtract 2. So x is 6. If I put in 2, this is 4. So I subtract 4, and I get x is 4. So I'm right 8, I'm right 6 up 1, and I'm right 4 up 2. There's my line. The your turn, my turn problems, we have to distinguish the fact that on A, y is by itself, so we should start with x's, and B, x is by itself, so we should start with y's. I'll let you guys fill in the rest and try those on your own. The second way to graph lines is by finding their intercepts. So the x-intercept is where the graph crosses the x-axis, and it looks like a comma 0, where a is any number, and we have various pictures. So if we look at this, your x-intercept is here, and we're going to abbreviate intercept to int. You could also have this line, and here's your x-intercept. You could also have this line, and this is no x-intercept. It never crosses the x-axis. If you can have an x-intercept, you can also have a y-intercept. And this is where you cross the y-axis, so it looks like 0, comma b, where b is any number. So if we take a look at those pictures again, you would cross here. That would be your y-intercept. That middle picture has no y-intercept because you never cross the y-axis. And the third picture, here's your y-intercept. Right? To find intercepts from an equation for the x-intercept, we let y be 0 and we solve for x. To find the y-intercept, we let x be 0 and we solve for y. We only need 2 points to graph a line. Sometimes it makes sense to just find the intercepts to do that. So if we look at problem 1 to find the x-intercept, again it says let y be 0. To find the y-intercept, it says let x be 0. And then we have to do the work. So we have to put 0 in for y. So 5 times 0 is gone, so 3x is 15, so x is 5. If you put 0 into if you put 0 into x, 3 times 0 is gone. 5x equals 15, so y is 3. So we get 0, 3. And then we're over 5 as one place, and we're up 3 as the second. So 5, 0 is where we cross the x-axis, and 0, 3 is where we cross the y. If we look at 2, and we find the same, 0 for y for the x-intercept, 0 for x for the y-intercept. If we put 0 in for y, we get 6x plus 0 equals 0, so we get 6x is 0. So we divide by 6, and we get x is 0. So the x-intercept is at the origin. That's where the x and y axis cross. If that happens for 1, it will always be the case that they have the same intercept value. Now, 1 point is not enough to graph the line, so now we need another point because the x and y intercepts are the same ordered pair, and that's not enough to draw our line. So how about we look back at our equation and notice that y is pretty much by itself, so let's start with an x. So let's just pick anything. Let's let x be 1. So 6 times 1 plus y is 0. So that's 6, move it over, so y is negative 6. So our other ordered pair, we had x of 1, now we have y of negative 6. So we go over 1, down 6, and we draw our line. If we're looking at the third one, we let y be 0 for the x-intercept, x be 0 for the y-intercept. If we put 0 into y, we get 3x plus 10 times 0 is negative 6. This is gone. Divide by 3. So x is negative 2. So you get negative 2, 0. If you put 0 in for x, you get 10y equals negative 6. Divide by 10 and reduce. Y is negative 3/5. So that is correct, but the ordered pair negative 3/5, the ordered pair 0, negative 3/5 is very hard to plot. We can plot the first one. And then we need really another better point to plot, right? So we need another nice point to plot. So you could guess and check, or you could use your TI-84 calculator. So if we wanted to use our TI-84 calculator, we first need to take 3x plus 10y equals negative 6 and solve for y. So we're going to move this over. We're going to get 10y equals negative 3x minus 6. We're going to divide by 10. We're going to get y is negative 3/10 x minus 3/5. And then we're going to use our graphing calculator. So I'm going to open up my graphing calculator. I'm going to hit y equals at the top. I'm going to put in that equation. So I'm going to hit the negative key on my calculator, not the subtraction sign. So I'm going to do negative 3 divided by 10. I'm going to hit x up in the left corner where it has xt, a Greek symbol, and n. Then I'm going to do minus 3 divided by 5, and I'm going to hit graph. And here's my graph, right? So I can see when I move my graph around, right, that here's where it's at. Now to find another nice point above the word graph, it says second. So above the word graph, it says table. So I'm going to hit second graph, and I'm going to get a table. And I'm going to find another nice value. So if I look in my table, and I look at the X column, which is all the numbers listed first, I get down to 8, and I see that I have a nice value of -3. So that is going to be my other point I'm going to use, 8, -3. So I'm going to go over 8, down 3, and there is my graph. Now for 4, do 0 for y for the x-intercept, 0 for x for the y-intercept. If I do -2/5 times 0 equals x, I get x is 0, so we get the origin. Anytime we get the origin, we also have it for the other intercept, so we're here. Remember, if we get the intercepts to be the same at the origin, we need another point. Now I can freehand this when I can do this with my hand. If I look at my equation, my x is all by itself, so I'm going to pick a y. The y I'm going to pick is going to have is going to be the same value as that fraction's denominator, so I'm going to pick 5. So I get -2/5 times 5 equals x. 5's over 1, and those drop, so x is -2. So I get -2, 5 for my other point I needed to draw my line. Moving on, we're going to talk about horizontal and vertical lines. The graph of x equals a is a vertical line where a, comma 0 is the intercept, and y equals b is a horizontal line where 0, comma b is the y-intercept. So y equals 4 satisfies the second definition of being horizontal. So what that means is you go up to where y is 4, you plot a few points across there because y must always be 4, and you draw your horizontal line. It has a y-intercept of 0, 4. On 2, I'm going to get x by itself, and I'm going to get x is 6. So we see that that satisfies the first definition of being vertical. So that means I go over to where x is 6, and I plot a point, and then I move up or down and plot a second point. And there's my line. So this has a x-intercept of 6, comma 0. For the concept check, given the table, right, so it says the table of values, what would be the x-intercept? So when you're finding an x-intercept, you need a y of 0. So we would say -3, comma 0. The y-intercept, we need an x of 0. So we'd say 0, comma 2. Which equation corresponds to the table? Well, we have to guess and check. So what I mean is take -6, -2. Take this one. Plug it into all of these to see which one it works in. And you're going to find it works in this one. So that's your equation. To graph, just plot any of those 2 points. So I'm going to plot the 2 points I listed for the x and y intercept. So over 3, up 2, and draw my line. So that's finishing section 2.1.